Let's look at the series, the summation from 1 to infinity of 4 divided by n squared plus 4n. We want to know if this series converges or diverges, and if it converges, what does it converge to? This is an example of a telescoping series that we saw before. So first thing we're going to do is factor the denominator and rewrite this as 4 divided by n times n plus 4. We should write out the first few terms. When n equals 1, that's 4/5. When n equals to 2, that gives us 4 over 12. When n equals to 3, 4 over 21. When n equals 4, that's 4 over 32, and so on. And this is 4/5 plus 1/3 plus 4 over 21 plus 1 over 8, and so on. This is clearly not a geometric series because there's not a common ratio between terms. Next thing we're going to try is test for divergence. So we'll use test for divergence just to see if we can detect that this series diverges. We take the limit as n goes to infinity of 4 divided by n squared plus 4n, but this limit is 0, therefore the test for divergence is inconclusive. So what we're going to have to do is express our series using partial fraction decomposition. Let's take our term 4 divided by n times n plus 4. We want to express it as a divided by n plus b divided by n plus 4. We did this before when we did partial fraction technique for integration. Multiply both sides by the denominator on the left, and that gives us 4 equals a times n plus 4 plus b times n. And now we have to select values of n that will give us a and b. First value of n will be 0. That means that 4 is equal to 4a, and that makes a 1. Next value will take minus 4. That says that 4 is equal to minus 4b, and that makes b minus 1. Therefore, our series we started with 1 to infinity of 4 divided by n squared plus 4n is equal to the series from 1 to infinity of 4 divided by n times n plus 4. And now we can express it as the series from 1 to infinity 1 over n minus 1 over n plus 4. So let's recall how a series is defined. A series is defined by starting with a sequence. So sequence an of numbers from 1 to infinity, say, and the series is defined as a summation of the terms from that sequence. So it's a1 plus a2 plus a3 plus a4, but that is a sum of infinite number of numbers. And from here, to define it, we form a new sequence, Sn, using capital N instead of small n. This is now a sequence of nth partial sums. Sn is defined as the summation from little n from 1 to big N of a sub n, which is a1 plus a2 plus a3 plus up to and including a sub n. And then the series from 1 to infinity, an, is defined as the limit big N going to infinity of the sequence of the nth partial sums. If this limit is finite, we say the series converges to that limit. If the limit doesn't exist, we say the series diverges. Now in practice, it's very difficult most of the time to express Sn in a way that the limit can be computed. But in this case, we can do it. And the reason is, well, because of the way our series is constructed. So let's go back to our series. It is the summation from 1 to infinity. This is a telescoping series. 1 over n minus 1 over n plus 4. Most of the middle terms will cancel. What I always suggest is pick, instead of computing Sn, pick a number, not too high but not too low either. Let's select capital N equal to 8. So we want to compute S8. Start with 1. When we do that, we have 1 over 1, which is 1, minus 1 over 5. Now when n equals to 2, we have a half, and then minus 1 over 6, plus 1/3 minus 1 over 7, plus 1 over 4 minus 1 over 8, plus 1/5 minus 1/9, plus 1 over 6 minus 1 over 10, plus 1/7 minus 1 over 11, and then plus 1 over 8 minus 1 over 12. And look what happens. Minus 1/5 cancels with 1/5, minus 1/6 cancels with 1/6, minus 1/7 and 1/7 cancel, minus 1/8 and 1/8 cancel. Now what we have left are 4 terms that are added and 4 terms that are subtracted. So we have 1 plus a half plus a third plus a fourth, and then minus we have 1 over 9 plus 1 over 10 plus 1 over 11 plus 1 over 12. Now we can add and simplify 1 plus a half plus a third plus a fourth. That's 25 over 12. But we should not simplify the terms that are subtracted. We should express them in terms of 8. So like this, minus 1 divided by 8 plus 1 plus 1 divided by 8 plus 2 plus 1 divided by 8 plus 3 plus 1 divided by 8 plus 4. And so now, based on this, we can generalize this to a formula for Sn. Sn will still have 1 plus a half plus a third plus a fourth. Those will not cancel. So we have 25 over 12, and then minus 1 divided by n plus 1 plus 1 divided by n plus 2 plus 1 divided by n plus 3 plus 1 divided by n plus 4. And now this is a formula for Sn in terms of n. We can now finish the problem. So the series we started with was the summation from 1 to infinity, 4 divided by n squared plus 4n. We wrote it as the summation from 1 to infinity of 4 over n times n plus 4. After partial fraction decomposition, this is summation from 1 to infinity of 1 over n minus 1 over n plus 4. And now this is equal to, by the definition of a series, the limit as capital N goes to infinity of the term, the nth term of a sequence of the nth partial sums, which is 25 over 12 minus 1 over n plus 1 plus 1 over n plus 2 plus 1 over n plus 3 plus 1 over n plus 4. Well, this is an easy limit to evaluate because all of these terms go to 0 as n goes to infinity, and we're left with 25 over 12, which is the answer. So to summarize, we can write this as equal to 25 over 12. And in summary, the series, the summation from 1 to infinity of 4 divided by n squared plus 4n. It's a telescoping series in that most of the terms, when we compute the nth term, the nth partial sum, most of the terms cancel, and we're left with few terms. This series converges to 25 over 12.